Andrew Ginter is the VP Industrial Security at Waterfall Security Solutions. He recently published his second book, Secure Operations Technology. Andrew will be signing free copies of his book in the lobby after this session. Please welcome Andrew to the S4 main stage.
Hello, everyone. I'm here. Oh, there we go. I'm here to talk about Secure Operations Technology, my new book. Where to get started? Information security, ITsec, is all about protecting the information. Protect the CIA, the AIC, the IAC, the something of the information. What we observe secure sites doing in the industrial space is not protecting the information. Their goal is to protect physical industrial operations from the information. More specifically, protect operations from cyber attacks that may be embedded in the information. This is because all cyber attacks are information. Brain blank. Here we go. When Dale was promoting this session in the agenda, on Twitter, he described the new book as controversial. But all I do in the new book is describe what industrial sites at the high end of the bell curve do, what they actually do. For that matter, this is all I did in my first book as well. I don't see that as controversial. I see that as good reporting. What I think should be controversial is that I don't see anybody else talking about this stuff. Cyber attacks continue to become more sophisticated with more severe physical consequences. We're talking attacks on industrial control systems. All of us respond by steadily increasing the strength of our security systems to deal with this escalating threat. The entire bell curve of cybersecurity posture strength, the entire bell curve is shifting to the right in the direction of the world's most secure industrial sites, in the direction of the high end of the bell curve. And nobody else is talking about what those sites do. This is all of our future. We are all heading that way, the entire bell curve. This is all of our future. Why are so few people talking about where we are all going? Why are so few training programs teaching these techniques? That's what I think should be controversial. At secure industrial sites, what I see the sites doing is modeling all of the control systems, and there tend to be many control systems at an industrial site, modeling all of those control systems together as one large control critical network with lots of subnetworks. What those sites then do is carry out an inventory of information flows from outside the control critical network to inside the network. A comprehensive inventory of information flows into the critical network is also a comprehensive inventory of all possible cyber attack vectors. All attacks are information. With that inventory in hand, what we see these sites doing is systematically deploy technologies to control and to protect against those incoming attack information flows. These sites generally deploy physical protection, not just software. All software has bugs. Some bugs are security vulnerabilities. And so in practice, all software can be hacked. Trying to defend using security software full of vulnerabilities to try to defend a control system network full of control system software that's full of vulnerabilities, that's like trying to bail out a basement with a bottomless bucket. It's fun to watch unless we need to see progress. So, in fact, a thing that we see driving increased adoption of this SecOD methodology, of these best practices that I document, a factor that I see driving adoption is compromise. More and more sites are adopting these practices after they have suffered physical consequences of compromise, in spite of the software security mechanisms they already had in place. Now, don't get me wrong. The sites that are on the high end of the bell curve, the sites that practice SecOT, also use software protections. They use certified secure industrial devices. They use software update programs. They have secure communications. They use RBAC. They use secure software development practices. But they deploy comprehensive software-based ITsec protections at these sites. But they have no illusions about the strength of security, the strength of defense that they get from these software protections. They see these ITsec style software protections as secondary compensating measures. A second line of defense behind their primary defenses. They see their primary defenses as physical protection against attack information flows. Now, attack information, any information, can only move in two ways. It can move offline or it can move online. Offline attacks must be physically carried into an industrial site. It may be carried on a cell phone. They may be carried on a USB key. They may be carried in the head of an attacker. If I have attack information in my head, if I am an attacker and I have a password and malicious intent in my head, and I physically walk past a security checkpoint, I can apply that attack information through my fingers into the first control critical cyber asset that I come across. The offline controls that we see SecOT sites using differ. They're going to seem reasonably familiar to most of us. They differ from classic ITsec protections against offline attacks more in degree than in kind. What's different is the intensity that SecOT sites bring to the job of protecting critical networks from offline attacks. So for example, one new thing that we're starting to see SecOT sites do is establish cyber near-miss programs. These are like OSHA safety near-miss programs. Every message like, I just blocked somebody from mounting a USB drive, every one of those messages produces a cyber near-miss report that is aggregated, that is investigated, that is followed up on. SecOT sites report that the combination of cyber near-miss program and the offline protections, the strong offline protections from offline attacks, together effectively eliminate errors and omissions in the handling of USB drives, laptops, and other devices full of information. When it comes to online attacks, SecOT advice differs sharply from ITsec advice. SecOT forbids firewalls at the connection between a critical network and any external non-SecOT network. SecOT permits only unidirectional gateway technology at those boundaries of the critical network. A unidirectional gateway is a piece of hardware that is physically able to send information in only one direction. It does not matter if our attackers have found a zero-day vulnerability in every piece of software on the planet. It does not matter if they have stolen zero-day vulnerabilities in every piece of security software on the planet. It doesn't matter if they steal every password and every two-factor dongle for every account on every computer on the planet. It is physically not possible to send that attack information online through the unidirectional gateway back into the protected network. Now, I'm guessing that most of us have heard of this unidirectional stuff before. I'm guessing that most of us have either not really looked into it, or we looked into it a little and concluded it's not going to work for us. What's new in the book is a catalog of about 24 unidirectional reference architectures. These are ways of organizing critical networks in such a way that they can be protected unidirectionally for lots of different kinds of critical networks. These architectures are drawn from the experience of secure sites who've deployed this methodology. You know, this is reporting what people are actually doing out in the world. This part of the book is the one that is most likely to need updating a couple of years from now. We continue to see new architectures emerging from the experience of secure industrial sites. The last part of the book talks about risk assessment. At secure sites, what we observe is that the sites are looking at widely available, well-known attack capabilities. And they're comparing those attack capabilities against the defensive capabilities they have deployed at the site. The question they ask is, for each kind of attack, does this defensive posture reliably defeat that kind of attack? And by reliably defeat, they mean defeat essentially all of the time, 100.0% of the time. What's new in the book is I document a catalog, a standard catalog of 20 cyber attacks on industrial control systems, attacks with physical consequences. These attacks span a spectrum of severity of physical consequence, and they span a spectrum of attack sophistication. Secure sites use this standard catalog of attacks to evaluate the strength of a security posture at the site. They can also use it to compare the strength of security posture at different sites. To give you a taste of what's in there, have a look at attack number 10, the cell phone Wi-Fi attack. Cell phones are walking wireless attack vectors. Trick a few thousand somebodies into downloading a Trojan app. Because the app is useful. The world's fanciest flashlight app. The app can start sniffing for Wi-Fi networks, Wi-Fi hotspots. The app on a compromised phone can be carried physically deep into industrial sites that we might think are otherwise immune from wireless attacks because the site's so big, because the bad guys can't pick up the signal. The cell phones can. The Trojan app reports the Wi-Fi's and the GPS coordinates to an attacker. The attacker launches spear phishing attacks, steals the credentials to connect to these networks, and now the next time anybody carries any compromised cell phone back into the site, they can log into our control networks and attack us. They can be attacking us, sipping coffee in their basement, across the internet, from the other side of the planet. This is attack number 10. SecOT practitioners, by the way, are deeply suspicious of wireless networks. So, the people who practice secure operations technology, they like the approach for a number of reasons. SecOT is thorough. Give me a comprehensive inventory of offline and online information flows into a critical network that is intrinsically a comprehensive inventory of all possible attacks. SecOT is robust. Defend against those information flows physically, not with vulnerable software. SecOT people don't just throw software at the problem and hope that the SOC will catch the intruders before they've done damage. Physically protect. SecOT is disciplined. We do not see SecOT practitioners sitting on the edge of their seat playing whack-a-mole. The latest indicators of compromise, the latest actionable intelligence, the latest vulnerability reports. All cyber attacks are information. They will always be information, no matter how sophisticated those attacks become in the future. And so, SecOT is also future-proof. If we physically block attack information flows, we block current attacks and we block future attacks. So, at this point, I think Dale was going to come out and join us, and he's read the book and he has a few questions.
Good to see you.
Nice to see you.
Pick your favorite chair for the grilling.
There we go.
So I'm here with controversial author Andrew Ginter. And I read his book cover to cover. And it actually, first of all, let me give you the review for about 70% of the book. I think if you're looking for a book that gives you very straightforward, easy to understand advice on things like removable media, removable devices, test networks, emergency remote access, a lot of the things outside of unidirectional gateways, it's actually one of the best books I've ever read on that. And I say that because it reads like it didn't come from a committee. You know, it wasn't a group of people arguing over language and trying to, it's just very plain spoken, very clear, do this, don't do that. And I think it's probably things that most of the audience would agree with.
High praise, thank you.
Yeah. So I would say, you know, if you're looking for a book for those areas to, you know, to pass along to people, I think I definitely would recommend this. The other part that I thought was outstanding was those case studies for unidirectional gateways. So if you are going to use a unidirectional gateway, those case studies were great. You know, it said, here's a specific set of circumstances, here's how you use a unidirectional gateway. But there were a few areas, and I think let's address kind of the easy one, the older argument for a while. And this is, you know, always requiring a unidirectional gateway, because you say SecOT demands physical segmentation and protection of control critical networks from non-critical networks like the enterprise and others. Firewalls and other software segmentation may be used between ICS members of a control critical network, but not between a control critical network and any other network.
Yes.
So I think that's where the controversy is. And the real question is, what is the actual additional security you're getting for that investment and effort? You know, especially, it probably varies quite a bit by what you're allowing through your security perimeter. But if we take, let's say, a very firewall-friendly case, let's say you're sending PI data from your ICS to a DMZ or the enterprise. So source in your control critical network, destination non-control critical network, one port TCP 5450. How much actual risk reduction am I getting by replacing that firewall with the unidirectional gateway?
Our customers, the SecOT people that I talk about, they, again, are deeply suspicious of software security. You know, the NSA leaked 0 days in lots of major firewall vendors. Steal a password for the firewall and you can reconfigure it. Make a mistake in the configuration of the firewall and now, you know, stuff is leaking through. You know, maybe more telling, when you've got a firewall there, you give what I think is an artificial example. Nobody has one port open through the firewall. Over time, they open lots of ports. Modern attacks don't even like to exploit vulnerabilities. It's work exploiting vulnerabilities. They would rather exploit permissions and, you know, just come through the firewall that way. You know, theoretically, the risk is that every connection through a firewall that lets data out also lets attacks back in. Every connection through a firewall is bidirectional. There are queries going back in, there's answers coming back out. If we compromise a client, if we have an attacker with a foothold on the IT network, now they can, at their leisure, launch attacks through the firewall into the PI server. They can you know, be testing this on their own networks and come in with a proven exploit because there's a way to send attack information in. You know, you can contrive examples with, you know, the smallest possible, the most secure possible firewall configuration. What our you know, the people that I write about, the SecOT sites, they want enterprise-wide access to operations information, and they just want this risk of compromise taken off the table. Physical protection does that. There's no kind of software protection that will give them that same degree of comfort.
Yeah, and I think we could go into that quite a bit, but I want to kind of look forward to the future. But I think that's one of the questions that people always have is...
Yes. I mean, I do a presentation sometimes, 13 ways to break a firewall.
Yeah.
I bring a firewall in. I show people how to break through it.
Right.
You know, it's a popular presentation. People like to see things break. If I could bring something in that would blow up, I'd have a standing room only crowd. But the limitations, the essential limitations, not you know, I misconfigured the firewall. The intrinsic limitations are well known, and you know, the paper's on the internet. Google Ginter and 13 ways, and off you go.
So let's talk now about kind of the future. So we've had presentations from GE on Digital Ghost. We talked about the Purdue model and how that's morphing. And in your book, you flatly say operations from the cloud, such connectivity is forbidden. And I don't think anyone would argue that we want to allow some millennial in their basement to control our power plant. But what about the case now where you might have some of these cloud services that are performing level 2, level 1 operations, or probably let's start level 2, level 3 operations. They would be considered control critical networks. They would be, you know, quote, in the cloud or somewhere out on the broader network. How does that fit in with your SecOT philosophy? How would you address that?
Well, let me give you a couple of cases. I mean, the cloud, the industrial Internet of Things, a lot of people believe utterly that this is the future of industrial control systems. And so, of course, we need to support it. So let me give you a few examples of how it can be supported safely. And then let's come to your trickier question of what might be done sometime into the future. we do see people connecting control systems to the cloud. One way out, nothing comes back. We can use the information, large amounts of information, big data analysis for optimization. We can use it to identify potential failures. We can use it to generate advice that is going to make us more profitable. The question is, when all that information goes out, it'll go out through a unidirectional gateway. This is the philosophy for the SecOT practitioners that I document. There generally needs to be something coming back in order to act on that information. And I have that documented. What we observe people doing is they will do their best, and it depends on the vendor, they'll do their best to send the most abstract information back in. So a piece of information like an email message or an alert on my cell phone saying, one of the bearings on this pump on your pipeline, such and such an ID, is failing. You need to send a crew out there within the next 7 days or you're going to have a catastrophic failure. That kind of input back from the cloud, through my cell phone, through my head, dispatching a work crew, that is something I can verify for safety. I can verify that there's not going to be undue consequences, in terms of equipment damage or downtime. Or, I can verify that. If instead I delegate to the cloud and say, let me come to the tricky example in a second. A simpler example is I have a batch process, pharmaceuticals. I have a control recipe that comes into the plant saying produce 10,000 pounds of aspirin. A recipe that says produce 10,000 pounds of aspirin using raw materials in bins A, B, and C is something that a human can look at and verify visually that it's safe. A control recipe that comes in and says, okay, you've got 100 PLCs. On this PLC, these 73 registers get set with those set points, these 7. If the recipe information is in the business network and very detailed low-level instructions are coming in, there's no way a human can verify those for safe operation. There's no way a human can verify that they haven't been tampered with, and we're going to have, the thing shut down and scrap 10,000 pounds of product, or that we're going to have product come out that is not up to the standards, the quality standards that we need. There's no way to verify that. So when something comes back in from the IT network or the cloud, it should come back in as abstractly as possible, and ideally through offline means, ideally through the eyes of an end user, of an operator, to verify what's coming in. Your tricky bit, I heard you ask, can we make the cloud an extension of the control critical network?
Well, for example, you have in your book, you have an example with 2 power plants, right?
Yes.
So where you have 2 power plants, they're both control critical networks. They have a way of communicating with each other. And wouldn't the cloud just be another control critical network that we would have to secure and have some level of trust with?
The short answer is maybe. In that scenario, we had operators at the large plant remotely operating the small plant off hours because there wasn't a 24/7 operator at the small plant. If you look at the scenario, the example purchased a dedicated T1, T4, MPLS, whatever the nomenclature is nowadays, a dedicated telecommunications capacity between the 2 sites through a firewall on, and modeled both sites as a single control critical network, which meant there's no firewalls between that meta network and any external network like an IT network or the internet. If we were to say, let's take the small plant and pretend it's in the cloud, well, now we are going across the internet. You don't get to the cloud other than the internet. There are allegedly dedicated connections you can buy to the cloud, but they're expensive, and I'm told they're going away. So now we're going across the internet to the cloud, which is a very bad idea in the eyes of the people that I observe here. And B, we're allowing the cloud to, in principle, send very low level, if the operator's sitting in the cloud, second by second, they're sending very detailed instructions to this device, to that device, and who knows what the consequences are. Who's looking over their shoulder? Who's looking over the shoulder of anybody who's interfering with that communications or has compromised the firewall and is sneaking stuff in? That's not to say it can't be done. We continue to add new reference architectures to the catalog as people do this stuff. So we haven't seen anyone do this stuff. We are working with a number of vendors on ideas like this and looking for lead customers to deploy these things. And we're going to see additional architectures in the catalog. So let me give you an idea of what might be possible.
Okay.
Let's say we have a system in the cloud that has a model of the plant. We're sending large amounts of information out, and they've detected compromise of the plant. And they want to send a large batch of very detailed instructions in, saying disable this device, reroute that, very detailed instructions. The risk that our customers, that the SecOT practitioners I document would see is that that central site is a militarily strategic target. You talk about nation states. Who's the nation state going to go after? Are they going to go after a little natural gas distribution system somewhere? Or are they going to go after the vendor that's connected and that's controlling, directly or indirectly, a third of the nation's natural gas distribution? They're going to target the vendor. The threat is that the cloud is going to send us instructions that do very bad things to our infrastructure. Now, if the cloud has detected compromise, let them send us a message and say, I've detected compromise, here's my evidence. So that people at the site can very quickly check their own data and make sure it agrees with the evidence that's coming in from the cloud. Verify that, and then they've got to make a judgment call. Do I believe the cloud, or do I believe, Okay. And so at that point, they can slap the yellow button and say, emergency override, let those cloud instructions in for the next 60 seconds. Fix my problem. Because I've decided it's much more likely that I have been compromised than that the cloud has been compromised. So that's a possibility. I haven't documented that because I've never seen anyone deploy it.
Well, I want to hit a couple other questions, so let's try to knock these out quickly. What would secure OT say about wireless HART or ISA 100?
Wireless HART or ISA 100. So these are wireless protocols deep into the industrial network, yes, at the lowest layers. As I said, SecOT practitioners are deeply suspicious of wireless networks because they can be compromised so easily by wireless devices that we carry around with us. If we can deal with those risks by banning cell phones or by physical mechanisms of preventing attacks entering the site, as long as, the people that I work with, I think they would say that as long as the network is confined to a physical security perimeter, it's all inside the control critical network. It's part of the control critical network. Use software mechanisms inside the control network. Go for it. It is at the interface to the outside world that we have a problem. That's the short answer.
Okay. You also said in your book that it is better to separate an industrial control system data center from the enterprise data center. And that could be quite costly if you build a good data center. What is that something that you highly recommend, or is that just kind of a nice to have if you've got a lot of money?
I'm not sure that
or did I misread it?
I'm not sure you've understood it correctly. I think I said those words, but I didn't use the word data center. The example I gave was if I have a pharmaceutical plant, I've got 18 production units. Each of them has a 24/7 operator. Each of those production units has a server room somewhere. There might be a server room with 3 or 4 control system servers in it. There's going to be 2 or 3 IT server rooms in that facility in different buildings as well. What we see our most cautious practitioners do is deploy in the building the ICS server room in a different room than the IT server room. And the only connection between the two is that unidirectional one-way fiber optic cable. That's not the same as a data center.
Well, but your server room, you would want to have some sort of environmental controls and
That's right.
And you know,
And
a lot
it
of the
is-
things wherever you want to run servers
Yes.
that have high reliability requirements.
That's right. And you know, if we were to take, we don't see people taking one big server room and splitting it.
Yeah.
But we do see people when they're designing new facilities, designing them this way in anticipation of a SecOT approach to security, because they want to avoid errors and omissions. If you've got a technician in a server room that's got IT stuff there and ICS stuff beside it and a mishmash of wires, there's a risk that we're going to connect the wrong wires. And now we've got a direct connection between the control network and the IT network or the internet, which is a very bad idea.
Well, so maybe just to finish off, and I'll let you kind of have the last word here too. So I tried to follow my own advice in the keynote when I was reading your book. There were parts of your book that I had the knee-jerk reaction that just said, you know, that's just not possible. That's not the future. You're trying to hold back what the businesses will demand. But then I said, okay, well, wait, take a step back. Is there a way of applying these principles and still actually getting the services and living in the environment that the businesses are driving for? Or are we trying in this secure IT or secure OT to try to actually pull back what the businesses are seeing as the future in progress? And I guess that's why I was asking those questions about various zones distributed across a wide area, because to me, it might not be your secure OT, but there might be some middle ground where you can say we have a higher level of security that maybe isn't the same as our critical, non-critical communication, but we have another level for critical to critical communication that needs to be looked at. At least that's what I took from your book. But I want to get, you can respond to that, and
Sure.
please give your, you know, any last words you have. And just one more thing, everyone, he's got about a couple hundred copies, probably less than 100 now copies of the book out there, so you definitely should pick up a copy of it when we're done here, and I'm sure you'd be happy to autograph it as well.
Absolutely. Free of charge, courtesy of Waterfall Security Solutions.
Okay.
So to answer your point, SecOT is, you know, intrinsically, all security is about blocking certain kinds of activities, the activities that cause us harm. By definition, we block things in security. This is what we do. The goal is to block the bad stuff and still enable the business processes that we need to profit, to serve our customers, to serve our stakeholders. I don't have all of the answers. I've got 20 answers in the book, and we routinely work with sites to develop, to invent new architectures, new solutions, new technology when necessary. So this brings me. Let me leave a parting thought with you folks. What we observe of a lot of control system security leaders in the middle of the bell curve, I asked these people for feedback on my last book. The feedback that I've had from a lot of the leaders in the middle of the bell curve amounts to laughter. Ha ha ha, what are you guys doing? Can't you see there's no road over there? That's jungle. But cybersecurity attacks only become more sophisticated over time. All of us are improving our security posture. The entire bell curve is shifting in the direction of SecOT practitioners. In a small number of years, those same leaders are going to look around and say, whoa, what's happening? The herd is moving. Where are they going? They're going down that road. Where'd that road come from? Quick, run to the head of the pack and shout, follow me, guys. I'm your leader. That's not leadership. I invite the real leaders of industrial cybersecurity to join the pioneers, to pick up your machetes today, join the SecOT pioneers, building the road. We are building a road to secure operations, a road that everyone, sooner or later, is going to go down as the bell curve shifts. I invite you to join us. The world needs this road. That's what I had for you. Thank you very much. Thank you, Dale.
Thank you.